let's look on some other particle effects, and we look how to simulate some fluid or liquids inside the fluid. A couple things to understand. This is particles that simulate more single particles. They don't have a fluid physics or spring effects to simulate some cloth. So we have some limitations on how we can use it, but with some settings we can achieve similarity to maybe water flow and some other liquid effects. So let's begin. First, I'm going to create a cube so we can observe how the liquid will affect this. Okay, next I'm going to just place it above, creating emitter, and I'm going to use plane for that. Let's go select it. Okay, let's open material for this emitter, and I'm going to add ecosystem. Next we'll go to add particles, and I'm just using a simple sphere. Go enable particle motion for this. Okay, next what I want to do, it is actually take and reduce density, so we have it not so many particles. At this point, if we preview, we can see they're going through. So let's go on our cube, enable collisions. As well, we go on the ground and enable collisions as well on the ground. Right here we have a simple particles just going down. Let's go ahead and render so we can preview what's going on. Okay, you can see we have just single particles going. They don't look like liquid at all. To enable particles look like a liquid, we actually need to go inside global settings for particle motion and enable render as meta blob. So let's look first what does meta blob render. If we're going and create, for example, two spheres. Okay, this is one sphere. We'll copy another sphere. You can see the two couple spheres. Actually, you know what, let's create longer, so we'll make maybe this one will be smaller. So right here we have these three spheres. This is normal. You can see we can see as separate particles. If we combine them and creating meta blob, you can see on a screen they kind of creating this liquidity form. So what is happening when we apply meta blob effect to the particles that creating as water? They will create this form. The more particle closer, you'll see the more kind of liquidity you will have it. You can control how close they will detect when they start linking together, as well how much this bump effect will apply it. Let's go ahead and delete this. I'll open our again material. One thing what I want to do, I want to increase size. So when we're creating, it will be a bit bigger, easier for us to see these connections. Okay, let's increase a little bit bigger. Okay, next we're going inside global particles effect. We'll enable as meta blob. So let's check a couple things in the options of what is apply, which threshold, tolerance, and smoothness will give it to us. I'm going to move a little bit forward so we can preview. Okay, first, the smoothness will create how the connection will apply to each other. For example, the smaller effect. Okay, let's right now just preview very fast. You can see this separating. And this is actually will affect by threshold. So if we take our smoothness and decreasing to 2 example, you can see we increasing the size of them, so they will start detect and creating these bridges a little bit closer to each other. Okay, so if we set even to 1, smaller, we start having them closer, but we also have it, you notice on the smoothness, we have it now, these bumps start appearing. And it's kind of interesting effect because if we increasing flow, we can create a lava look with those bumpiness. But you can see right, for example, in this area with cursor, you can see you have kind of lines. So it doesn't provide this smoothness between. But again, increasing too high smoothness will reduce some of the particles connections. So if we're going, for example, 15, you can see we start losing them because it's trying to smooth and removing. Overall value from 5 to about 2 is good value to use it. It depends how turbulence water you want to create it. By default, it's COM 5. I don't recommend to set smoothness to the 0 because in that case, you just start too much calculations and it will look like your view is hanging around, but it's take forever to calculation. So at least you want to keep it maybe 0.5 around these values. And if you're going higher than 5, I don't know, probably about 8 maybe will provide you some effect if you want to have it single drops of the water going from like faucet or somewhere. This will provide you some nice effect, right? Example right here on meta blob, but you start losing with some start reducing this kind of connections, so become too small. I'll show you in a second some other how you can increase this way. So this is our smoothness. Let's set back to the 3 for this one. So right here we have it. Next, the tolerance, it says effect when is detecting the next particle. So you can increase tolerance, but it will create a little bit more errors when it starts detecting other particles. The best keep it around 0. If you want to increase a little bit speed, you can increase tolerance higher. But again, it will may create some errors when it start generating meta blobs. Okay, threshold, it's used to inflate or deflate the surface by the blobbing. So example 0.3, and we can go set to 1. Okay, let's click recompute it. You can see we reduce it quite a bit. Again, we have a nice kind of this meta blob particles, but again we lost some. With higher tolerance we lost those connections. So instead we're going to 101. So you can see we have it more connections, but again now we have it kind of more blobby look. By default 0.3 have a nice effect. You can probably going to 0.5 without losing too many connections, but it seems provide you nice smooth effect. So let's leave it 0.3 at now. Okay, couple tips when you're kind of creating this. It doesn't look like a liquid at all. The one thing what I recommend for you, it is set as 360 population. So you notice we produce more particles, but now because they produce from all surfaces, more of them kind of coming at the same time, creating this effect of stacking, so it's more looking like a liquid. The other also what you can do, you can increase a little bit simulation rate. For example, if we're going to 35, it will produce more particles. And of course the next, if you go to density and you increase density higher, they will produce also more particles, which is creating more look like a flow. And right here you can see we have it look like already water. Next what we need to do is work a little bit on materials to create its water effect. If you increase, let's go to 25 about, get quite a bit more. If you want to create simulate some other ones, for example right here more look like liquid, you need to go inside the smoothness and maybe set this to 1. With this effect you can create more look like a lava. You can see we have those lines applied, less smoothness, so you can create more rocky lava look with this effect. Okay, so also you notice right here on the side we have a collision detection. This is our tolerance. You can increase the tolerance also on detection, so it will be provide easy, kind of better look, a little bit more accurate. But sometimes with water you want going sink a little bit more below, so you probably even want to decrease some tolerance detection. And other things what you don't want its collision with the other particles. So let's say we enable this. Okay, in preview, and you can see we start losing. However, it is creating this interesting effect when particles kind of water splashing all over places, but because the tolerance is this way, you can see we start losing this water meta blob effect of this. If you want still flat splash kind of to do, you want to reduce tolerance. So let's set 2. You can see the tolerance of detection on particles. So if a little bit more create on splash, we just go create, let's say 1. Okay. On this case with tolerance, we still have this distribution like water, kind of starts spreading when it's going down with single particles. But we still have it also main flow of the water. So, and of course, if we're going and set tolerance to 1.9, reduce even a bit less. So they're kind of keeping a little bit more together and provide same effect. And of course, if we're going inside right here, smoothness, let's set smoothness back to 3. So it provides a little bit more liquidity and single particles. You also can do detect on collision right here, maybe based on time, and let them create in smaller particles. So this create almost like a splashes when it's hit down. This is another ways. But you can see right now, even with this effect, we have at one single point, water kind of starts spreading and going a little bit more, acting like a fluid, kind of going from top. Of course, the next things what you want to do is inside particle itself, change work on a mass, drag coefficient, and elasticity. So, for example, for the bouncing, when water kind of going down, we probably want set 50 and maybe 15%. This is variations of this. Okay, in this case, if we regenerating, you can see the water kind of bouncing like right here, this effect. So a little bit more look like it's real splashes happening. Okay, example right here, let's render. So right here, because we have this elasticity, we may want to decrease a little bit, but again, this way, if you simulate animation flow, you want to provide elasticity, maybe even 50 too much, maybe going to 40, a little bit less. Also, we can take a drag coefficient, enable this one, and set to 2. And depend on a surface, if we want to keep it a little bit more, we can enable also adhesion or stickiness on our surface. We can go set this maybe to 15, so some particles kind of create a wet surface, so they will be sticking around on this around there, and we'll set 25 on the variations. In this case, we'll have it some water or particles will kind of start sticking, creating this path for us. Okay, and again, if we're going a little bit more right here, and smoothness, maybe tolerance and smoothness, but again, right here we have a little bit more violent. You can see the bouncing splashes creating some stickiness right here happening in water, so we have it kind of fill up, more look like a water. Okay, we'll go right here. Let's go to this one, and we can actually threshold maybe set to 2, smoothness to 4. Just small adjustments, so we'll have it a little bit better kind of covering right here. There you go. When you're done with this, you can always go and edit material. So we can go preloaded already created liquid. So let's go just select one, click OK. And let's preview. You can see we have it, large particles. What happened because I did create a large size. If you need decrease, we go in a scaling, and right here reduce, which is pop-up quite. Besides creating a water liquid, you can also use similar simulations to create maybe avalanche, like in a tutorial. With avalanche, you probably want to increase life of the particles and emit more like snow, dust, other particles around from this. The tip and suggestion for this, I do recommend to go to the on your particles to the depth and kind of set live for these particles, maybe around 5 seconds, or what animation you want to do, just in case if you need preview more, you kind of particles start disappearing, so you won't have this overusing. You can see right here particles does not kind of collect, so it doesn't overload and overuse the view with the simulations, all of these ecosystems, the populations. Thank you for watching this tutorial from Geekatplay Studio. Please remember visit on the web is www.geekatplay.com.